C6.1 Electrolysis. First step, we need to define electrolysis. What is it? It's a method used to extract metals that are more reactive than carbon from the compounds. Those metals are potassium, sodium, lithium, calcium, magnesium, aluminium. They are all more reactive than carbon. All the other metals can be extracted using the blast furnace method, which means it's heated with carbon here. That method won't work for these metals, so we have to use electrolysis. Electrolysis is more expensive than using the blast furnace. So electrolysis is only used for these, extracting these metals. What else do you need to know? You need to be able to draw a simple diagram to show the equipment that's used and label it. So we have a container here, and in that container we have a substance, an ionic compound containing the metal. So for instance, copper chloride here, not a good example. Let's use calcium. Calcium chloride, which is put into this container. Now it can either be heated up, melted, or dissolved in water. So there are two approaches to doing this. Both of them work. So an ionic compound containing a metal more reactive than carbon, put into a container, and it's melted or dissolved in water. We then add two carbon electrodes. These can also be metal, as long as they conduct electricity. And they are connected to a power supply here. Okay, so that power supply connects both electrodes, which means this side here will be positively charged and this side here will be negatively charged. Okay, so that's the equipment. Oh, we also need to know what that liquid is called. So when we take calcium chloride and we dissolve it or melt it, it is known as an electrolyte. Okay. So they're the key words. How does it work? When calcium chloride is dissolved or melted, it produces two ions, and those ions will be Ca2+ and Cl-. So we can represent them very simply like that. When we switch the power on here, an electric current is produced and electrons are pumped from the positive side to the negative side. So the electrons move this way. And the electrons accumulate on the negative electrode. So this one becomes negative, this one becomes positive. As a result, those ions which are in solution, they're free to move around. And what happens is the positively charged ions are attracted to the negative electrode. The negative ions are attracted to the positive electrode. So the opposite charges attract each other and those ions are separated. The calcium will accumulate on this electrode and they'll coat it. You might also get a deposit of calcium underneath. The chlorine on this side, as soon as it touches this electrode, it becomes chlorine gas and escapes, so Cl2 gas. So we're now separating those two ions into solid calcium, no longer an ion, and chlorine gas, no longer an ion. They can both be collected and used. So that's the method. One other piece of information you will need These two electrodes have specific names. So the negatively charged electrode is known as the cathode, and the positively charged electrode is known as the anode. So you'll be expected to know the names of those two. So the anode has the positive charge, the cathode has the negative charge. Finally, you'll need to write some equations to explain what happens in these processes. So we'll keep that nice and simple. So we'll just do a couple. So if you want to do a simple equation to show what happens to calcium chloride, and that is a liquid, it separates into calcium solid, which we're doing in words, plus chlorine gas. And that can also be written like this: CaCO2 breaks down to give calcium solid plus chlorine gas. I just need to balance that. No, we don't need to balance that, ignore. It's already balanced. Okay. So state symbols are required. L means liquid. S is solid. G is gas. And another one which you will come across is AQ, which means aqueous. And that means dissolved in water.